In question 4 of your report, you're asked, was your experimental percentage of water higher or lower than the one obtained via TGA? Now, to answer this part, you will want to go to Moodle and look for the data for TGA. These are the graphs for TGA that were done by Dr. Ben. These were run from your sample. So you'll want to use one of these graphs depending on your unknown. Like this one is unknown A, this is unknown B, this is unknown C. You'll want to choose one and find the actual accepted value that's under your data table of the percentage of water, because what you looked for in your experiment is your experimental value. So you use those graphs to answer this question. And how do you find your accepted or acceptable percentage value of water in your sample? The way to do that is to follow what's written on your manual, what's shown on your manual. Like this is an example of a TGA graph, right? This is a TGA graph. So the way to interpret it is to draw an extrapolated line touching the y-axis and read that value. Draw an extrapolated line, read that value. For example, this value is the same as the mass of the hydrate that was run in the instrument. For example, here you are given the mass right here. So you expect 6.59 to be the same mass right there. And then after heating, the mass will drop because you are losing water to a certain value right there. So you have to extrapolate a line and read the value. The difference between that mass reading on the y-axis and the mass reading on the x-axis is the mass of water lost. Okay. So for example here, if I were to extrapolate using a ruler, I would draw a line from the lowest part possible. You have to use a ruler and read the value on the y-axis. So again, this value here is accurately that number before you heating. That's the mass of the hydrate. So the difference between these two guys is going to be the mass of water lost. This is mass of water lost. Okay, so if you want to find the percentage mass using the TGA graph, is going to be equal to percentage mass of water using the TGA graph is going to be equal to the mass of water lost, which is what you got here. Let me call it X. Let's call this X, divided by the original mass of the hydrate. Let me call this Y. The original mass of the hydrate was Y. Okay, and then you're gonna multiply that by 100. That's gonna give you the accepted. That's gonna give you the accepted percentage value of water. Okay, because the instrument is very accurate. So this sample unknown C should have the exact percentage of water value given there. Remember, the mass of water is the difference between the mass of the hydrate and the mass of the anhydrous. The mass goes down because you are heating the sample in the instrument. And then use this formula right here. Percentage mass of water will be equal to the mass of water lost divided by the original mass of the hydrate, which is the mass given up there, times 100. That gives you the accepted. You use the accepted value on here. Okay, so that's the value that's gonna go on here. Okay, mass of the hydrate is what's given on the graph. Okay, this was my Y on the graph, so that's my Y on the graph, this number right here. And then the X is the difference on the y-axis. Okay, mass of water lost is the X on the y-axis right here. Let's see, so right there. And then this value right here is the percentage, of X, or just use the formula, is the accepted value. Use this formula right here. Okay, now the experimental value is what you calculated, right here. That's the experimental value. Okay, and then of course the percentage relative error you can find that using this formula in your, where is that formula? You can find that using the formula in your manual. Let me scroll and show you where the formula is, which is just percentage relative error. Is here in your manual, is equals to experimental value minus accepted value over accepted value times 100. That's how you get the percentage relative error that goes on here. That goes on here. Okay. So I've shown you how to find those numbers. So you should be able to answer question 4 right now. Okay, disregard this. This is not a number. You should be able to answer question 4. So based on your accepted value, compare it with your experimental value and provide a cause of the reason why probably your experimental value was higher or lower than that. Probably you did not heat enough, or probably you heated it and left it to stay around in the air, and then it absorbed the moisture, so the mass of the water lost became less. So, and then suggest how you'll improve such errors on there. So again, find these charts on Moodle. I'm gonna post these charts on Moodle. Depending on your unknown, you choose the correct chart, and remember this mass is the mass of the hydrate. And then remember again to extrapolate and then subtract. The difference gives you the mass of H2O. I hope that helps. Complete the report.